and label the coordinates with no numbers. So completely independent to yourself. You have a graph here. I want you to draw a shape and label the coordinates. And we're going to figure out if you drew a shape or not. So draw a shape. So let me give you an example first. What shape should I draw?
Rectangle.
So okay, triangle's fine. So a triangle, and there's a smart way to draw a triangle, and there's a not so smart way. I'm going to choose the smart way. I'm going to do it like this. Yeah? And I need to label the vertices of that triangle. So what is the coordinate location of this vertex? 0, 0. What is the coordinate location of this vertex? It is no.
Is it 0? Or A0?
We can say A0 if we want to. And what is the coordinate location of this vertex?
We say 0C. 0B.
0B. Did I draw a shape? Is it a triangle? Triangles are easy, guys. They're super easy. Now, when we get to stuff like this,
We don't know the quadrilateral.
so right now it's a quadrilateral. But how could I make it a trapezoid?
The legs.
So do the legs have to be congruent?
They have to be parallel.
The bases have to be parallel. So what are we going to call this vertex?
0.
And you want to go A0 right here?
BC.
Where?
Yeah.
That BC would not work right here. So if it was negative A, B, it would be, does that make sense? Like it would preserve this A. This, I could say negative B, negative C. You see it makes sense? It has to be B backwards and C down. What's that? You can if you want to. It's just practice. I gave you 4 blank ones. Alright, so let's just hold on right there. Is anybody, it took us a little bit of time to get here. Is everybody comfortable with what we have there? No? I just created it right here. Literally. Now there are instances where you can create variables. You can just reach back there and throw it on the paper. And there are instances where you cannot. Alright, so if you have the ability to not create a variable, I'm going to ask you to not create your own. But in this instance, yes, we did just create C. I went B backwards and C down. Now be careful how far down did I get to this one.
Negative.
I had to go down C units.
What the heck?
It's X and Y coordinates. Remember, Y goes up and down.
B negative. Or A negative.
B, it'll be a new variable.
C is
Okay, so here's an instance where I do not need to create a new variable.
Or you just say A plus B.
So how long is this piece right here? B units. But it's B units backwards, but this piece is B units. How long is this piece? So this one would be A plus B.
So you would just assume that those add up to that?
I know that they do. I know. So let me put a number there. Let's call this A units. Let's call it 3. And let's call this one 1. So how far is it from the y-axis to this point? 1 or B units long. So I go negative 1. That's right, I get there. How far is it this way? 3. So 1 plus 3 is 4. I went over 3 units plus 1 more, and I have created an isosceles trapezoid. Okay? These two lines are parallel. And you can do that by verifying the slope formula. So we have 2 more, right? 2 blank ones maybe? Challenge yourself. Draw something. Draw a shape. Try a quadrilateral, no triangles, please. You don't have to. I don't know what I'm doing. A lot of people are doing that. Okay. So I'm seeing a lot of B's, which is fine. How many of you guys have something like that on your paper? Which is great. And Vic, you have over A up B right here, correct? So if you go over A and up B, you would have to go over up B.
So can I just use like A, B every time?
Yeah.
I thought we had to incorporate C somehow.
Sometimes you can, sometimes you don't have to. So what would this one be?
Negative A, negative B.
Oh,
Wait, it's positive A, negative B. Yeah.
which is fine. What else? What you got? You did a parallelogram. Let me see what about your finger. Or should I invite you to the board and draw it? No, you good? So what do you have right here, Bryce? 0, 0. Any confusion on that? Okay. Now what do you got? What do you have right here?
I have
A, 0.
above that.
Right here?
Yeah, A plus B, and then C plus B becomes C. And then to the left, I have B becomes
Does that work? So it is over B up C to get to here. So this distance is B. This distance is A. So if I go over A and over B more, I get to that location. So we just chose to make his Y value C. Alright, that was the next one I was going to look at.
Zero A.
So you went 0A.
Negative B A. Cause I did B for this line.
So you have negative B A. So I know that this distance is A and this distance is A.
Would it be negative
Okay.
I didn't have the next one.
So if you go A down, this one has to be A down. And if you went B to the left, you can go B to the right.
I just didn't know if there was gonna be like that adding one.
I've got one. It's an offset.
Offset rhombus. Is it on the x-axis?
Yeah.
What about this one?
It's off to the right.
That's what I
Like that?
Yeah.
Okay, what do you got?
So for the right point, I've got A comma 0.
Over A, up 0.
For the top point, I've got negative C comma B.
What do you have right here?
negative c minus a comma 0.
Would it be negative a 0?
Hold on.
It's not the same.
Negative c minus a.
I thought I heard times.
Negative c minus a. Negative c minus a comma 0. So you're saying that this distance is c long, right?
Wait,
Does that make sense?
oh, I messed up.
Oh, you're good. So I'm trying to think through it. You go over c units, and you take a away from that, right? Because you have, this is c units long.
You're starting from the first point.
No, the top one, the top middle one is c. It's negative c comma b.
This is negative c comma b.
Yeah.
So from here to here is c units long.
Wait, who made this?
He did. You
No,
showed me.
not this. I mean,
Oh, the concept?
yeah, it sounds like.
So negative cb, you're good there. So then what does this one have to be?
Negative c comma negative b.
Okay. Now, here is an instance where you don't need to create a new variable. Is everybody on board with that? You don't need to. So, this distance is c, this distance is a. So, theoretically, that the distance from the midpoint this way should also be c and a. Does it make sense? So this location should be negative 2c minus a comma 0. It's weird, right? So it's negative, it's 2c to the left and 1a to the left. Because in a rhombus, the diagonal bisects it and it gives equal distances. That's a tough one. That's the property of a rhombus. Okay, so let's just give you a sir. Hurry. Alright, let's go through the notes here. So, pre-drawn shapes, it says this is a rhombus. We're just asking you to fill in the blank for the missing vertices. Who wants to do M? Tonight.
That one's 0, 0.
Too easy?
I'm trying to do n.
Alright, go in.
But like, I was gonna say like, it's 1/2 of a.
That is perfect. Uh-oh. It's half of A. Why? How long is this distance?
A.
And then when the diagonal cuts it in half, we should get half of A here and half of A here. So this is 1/2 of A. And what is this one? Half of A, comma,
Negative b.
negative B. So, technically you could call that like over C and up B, but it's more geometrically correct to call it half of A.
Do you have to do a negative?
For, yes, so right here?
No.
No, because it's still 1/2 A in the positive direction.
Oh.
Alright, homeboy, the square.
Oh, that one's X.
Which one?
C.
Over X, up
X.
Couldn't you just put whatever?
Well, I mean, how long is this distance? So how long should this distance be?
X. So X.
Oh, it said it's
It's a square, right?
Oh, I didn't even see that.
so everything should match.
Not everything.
Oh,
Oh,
that one's
no,
0x.
It would be 0x, but
Yeah, I understand what you're saying, but you just didn't say it correctly. So we're only using one variable.
Yeah, well, I think the square is the easiest.
Square is the easiest one depending on where it's placed on the coordinate plane.
Well, it'll have the same.
Parallelogram. Okay, so here's first question. Are we creating new variables? No, absolutely not.
Is it K plus X?
So this distance is x. This distance is k.
K plus X.
So this distance should be x plus k or k plus x, however you want to see it. Up m. This is as bad as you guys thought it was going to be? It is?
Yep.
Hey Dan.
Sounds pointless. Like what?
Rhombus.
Zero.
Negative A.
Zero.
See, that's easy, but I'm not gonna get it.
Why not start right now?
No.
So, remember yesterday how we said, can you prove it's a rhombus? So how do you prove something's a rhombus? All sides are equal. So how do you figure out if sides are equal? You have to use the distance formula. So let's find the distance from here to here. You ready?
Nope.
On your notes from yesterday.
X2 plus
x2 minus x1,
squared.
y2 minus y1.
That is zero.
So a minus 0 is a, and a squared is 0 minus b is negative b, and negative b squared is
B squared.
positive b squared.
Those can't be added.
No, that's it. The distance from y to z is the square root of a squared plus b squared.
So those pi
That's it. That's the answer. And you just leave it and trust it. So let's find the distance from here to here. So we'll do x2 minus x1, y2 minus y1. What's negative b squared? So
They're all equal. So
So are my two answers the same?
Yeah.
They should be because it's a rhombus. Is it always going to be the square root of a squared plus b squared? No. It might just be b squared. It might just be like a minus c squared plus negative b squared. It's be weird stuff. So we could continue around the deal. We can also do this. If this is a rhombus, shouldn't it have two sets of opposite sides that are parallel? Yeah, so let's determine if this side is parallel to this side. It looks like it, but we can verify it. So we have x1, y1, x2, y2. So the slope formula is y2 minus y1 over x2 minus x1. And here's where you guys get a little weird because there are no numbers here. What is negative b minus 0?
Negative b.
And 0 minus negative a.
positive
A. Now look at that. Is that a negative number? Is that a negative slope? So we check. You can kind of check that box off. The slope of this line is negative b over a. Same thing over here. x1, y1, x2, y2. y2 minus y1 over x2 minus x1. Turned into a positive. Are these two slopes the same? They are parallel. So it is a parallelogram. Cool, right? You can do math with no numbers.
Oh my god. We just said let's put them letters in math.
And that one's
But
A negative
is
A.
going-
A
oh,
negative
Right, so when you read it, and this one would be
That doesn't make sense.
why not?
Because them girl have to make equally sized square.
They do.
That's A.
Let's try
that's
it.
A,
Matt's like, no. So how long is this line?
A.
A. So I can do the distance formula to prove that?
It's a square.
You're good, right? So I get x2 minus x1 plus y2 minus y1 a minus 0, a, 0 minus 0, 0 squared. What is the square root of a squared? It's a long. So if I do the same thing here, it will be a long. So that's why I went over a down a. Huh? It's a square, yeah. The slopes will work out the same. It should give me 2 zero slopes and 2 undefined slopes, even though I have no numbers there. Just so beautiful. Yesterday was super boring, like you do things over and over and over again, scaling. Now you get to do things and they come out with just random answers. All right. Let's see. Let's do this one, number 5. It'll be the last question for this kind of topic here. We did number 4 quite a bit throughout the lesson, like show it to square, show all 4 sides are equal. So I want to do a different one, which is prove that it's a rhombus. So what is the only characteristic that makes a rhombus a rhombus?
All sides are equal.
All sides are equal. So I have to do the distance formula 4 times to prove that all 4 sides are equal. Can you guys do this with no picture?
Yes. I mean, you can,
Yeah,
but I feel like it's
Or would you prefer to draw a picture?
Yes. Yes.
So sketch a picture,
But how would we know where,
because it tells you where all the points are.
Oh, I can't draw a straight line.
Over A, up 0. This is where we have to like label our points with like 1s, 2s, and 3s, and 4s. What?
I like don't understand the letters part. Like, where they go.
Okay, so it says, this is kind of like x, y. It says move over A units and move up 0 units. So I went over A, up 0. That's where point 1 is.
You can make up.
Then I have to go over 0, up A plus 1. So that's like something like right here.
Yeah.
It's up A and 1 more.
Wait, then I thought A was to the right.
But A is the x coordinate, so move over A and go up 0.
But then the
Now
next
in this one, they're saying go over 0 and move up A plus 1. So A is a constant here, but it's a variable. So moving up A units, I don't know how far that is, but I want to go 1 more than A. This one says move back A units. A to the left, up 0. And this one says over 0, go down A and 1 more. So I get this shape that looks like this. And it's my job to verify that each side of that rhombus has the same length. The distance formula, we have to do this 4 times. So here's what's going to happen. I'll do one of them, and then you guys will do point 2. Well, let's see, how are we going to label this? So this is the Baker side, this is McKell's row, this is Kat's row, and this is Tyler's row. So all you guys, the whole half of that over there. So I'll do this side over here between point 2 and 3. So I gotta find point 2 and point 3. This is the one that I'm doing.
so we're just looking, so can we like look for the slope, or do we have to do?
It has to be distance. I have to label my points. X2 minus x1 squared plus y2 minus y1 squared. That's nasty. So negative a minus 0 is negative a. 0 minus a minus 1 would be negative a plus 1 squared. Because I have 0 minus a minus 1.
What's like?
So I can't really do anything with this, it's just negative a. But what's 0 minus 1? Negative 1. That's why I have negative a plus 1.
I don't
Right?
really know how to do that.
It's 0 minus a minus 1.
No, I'm confused. Because on my paper it says negative a minus negative 1. I mean, wait, negative a negative 1. Sorry. What do you think?
Yeah, you can't do this in the calculator.
You can't.
I
figured out
square root of.
Hold on. What's
I'm just confused. I don't know how to do negative a minus 1. Like, you can't. Wait, can I just do
oh? So how do you square that?
Wait, but you can't negative a minus 1. That's so.
Yeah.
I'm doing this one right here.
I'm
You
confused.
said it was number 4.
I was doing number 4 and I was so confused. Congratulations.
I changed it.
I remember M being 1 4. Oh, never mind. Did that.
Maybe it's 1 and 2. Okay, here's where I'm stuck. 0 minus a minus 1.
So negative a plus 1.
Wouldn't it be like 0 minus a would be negative a, right? And then
Well, you have to
0
distribute the
minus
minus.
negative 1. So if I distribute the minus,
So just be.
It's going to be negative a plus 1.
it's negative a plus 1. That's what I have right here. So negative a squared is a squared.
So negative a minus 1 minus 0 is just negative a minus 1.
Plus a squared minus 2a's. Well, here, I'm going to cheat.
Yeah. Hold on, give me
So what is the square root of a squared? A. And the square root of this quantity will be that quantity. A minus a
Oh.
is just 1.
So a squared minus a plus 1. I don't like how there's not numbers that you can actually.
Yeah, I think it's 1. Anybody else get 1? Or you get something different?
Oh, I got 1 and 4 and I got the same thing.
You got 1? You got 1. Which one? Which one did you do?
I did C.
You did this piece right here?
Yes.
the
Wait, that's my piece.
square root of 2a plus
That's our
1.
piece, right? That's our piece.
That's fine, you can do it. So,
If I'm doing it.
You're probably right. I just have not done
what'd you get for your formula, Scooper?
What?
Oh, right.
Yeah, so I did 2.
So did.
Hold on.
I did question. I did a minus 0.
A minus 0. And then 0 minus negative a minus 1.
Yes.
How did you?
Alright, did you get a plus 1 right here?
Yes.
So this would be a plus 1. Which should be 2a plus 1.
I got 2a plus 1.
Oh, you know why? So this would be 2a plus 1, 2.
Yeah, you should.
Alright, I've lost you guys, right? You see how nasty this can be? So, I'm gonna do this one with you guys. This is the new stuff, so, this is the other half of the worksheet you're gonna get on Friday. So I'm gonna do one with you, and that's gonna leave 2 for the back. These work out substantially nicer where we don't have like crazy quantities there. I'm pretty sure I should have skipped that one. Or I should have practiced this by myself. So this is the last part of coordinate geometry. We're gonna do some proofs with this. Oh yeah.
You know how to solve it.
Sure. All right, so the paper says, and it gives you a hint. It says, use the distance formula to prove that shape is an isosceles trapezoid. It says, prove that diagonals AC and BD are congruent. That's one step. All you have to do at the very bottom is prove that AC is equal to BD. Once you prove that, you're done. So how many times do you have to use the distance formula? Twice. You have to find out what is the length of this one and what is the length of this one. You have to prove that those two blue lines are exactly the same length. So I think I was trying too hard earlier, and we can probably stop this a little sooner than actually solving the whole distance formula. So let's do AC first. I'm going to choose these 2 points as my x2, y2, and these 2 points as my x1, y1. So I'm going to get x2 minus 0 squared plus y2 minus 0 squared. We good there? So 2d's minus 0. It's 2d squared plus 2c's minus 0. Okay, hold on. Any questions about why that works or how that works?
That's just the answer.
No.
I mean, 2D.
I'll just make sure that we're able to get from here to here. We good? So remember, we have to square these quantities. What is 2d's times 2d's? So 2 squared,
4D squared.
4d squared, and 2 times 2,
4C squared.
c times c. So we just executed the squaring part. Now what is the square root of 4?
2.
The square root of d squared. So I'm just doing this by pieces. The square root of 4 is 2. The square root of d squared is. The square root of 4 is 2. The square root of c squared. So the distance from A to C is 2d plus 2c.
What if it's not a perfect square?
Then you could probably stop right here and leave it there.
Okay, that's how
the
I was
square root of the square up there, then you still have it there.
Where, right here?
Yeah.
So this is just doing the subtraction part. 2d's minus 0 is 2d's, but I still have to square. 2c's minus 0 is 2c's, but I still have to square. Then from this step, I squared them. I only squared them. So 2d squared is 4d squared. 2d squared is 2d squared, or 4d squared. 2c's squared is 4c squared. Then I actually computed the square root. The square root of 4d squared is 2d. So you do the same thing over here. So this is not what you have on your paper, is it?
No, it's
No,
number
we do.
3. It's on the back.
It's on the back. We just found it on the back.
What?
I think I have it.
Huh?
No, I get that as
Okay, so tell me where you lost.
everywhere.
Everywhere?
Yeah, I don't know.
I was lost until I figured out how to solve it.
Okay. You're gonna hate me for this, but this problem will never work. Because I'm doing the wrong problem. The way that variables are set up, this will never work. Ever. The
I just
per-
did the same distance formula. Why did
Oh, but isn't, we didn't see it the exact same.
I know, I told you, I'm sorry. The purpose of this was for number 3. Because you see how those numbers match up perfectly to number 3 on the back?
Yeah.
So that's the one we should be working on.
I was doing number 3 on the
What's
back.
different? Yeah.
Okay, so on the back for number 3, it says prove that XY is the mid segment of the trapezoid.
So you have to find the distance.
So if you look at number 1 on the front, it says prove that the
Distance,
Oh,
distance
that's what you were.
divided.
that's why I was screwed up. They're both trapezoids, but I screwed up. So if I'm actually doing number 3, I'm trying to prove that XY right here is 1/2 the length of A plus B. Substantially quicker proof, I promise.
Let me just.
So we have to prove that this formula is correct. We have to prove that that's correct. It says that prove that 1/2 of DC plus AB is equal to XY. Now we're going to cheat here a little bit because we're smart, right? How long is this line?
2A.
I went over 2A. Do I have to do any proof stuff there? So how long is AB?
2A.
So 1/2 of 2A plus, now how long is the line up here?
Would it be
2B plus
2B
2D.
plus 2D plus 2A? Oh, no, it's dumb.
It tells you the trapezoid, so when you need to
2B plus 2D.
So if you don't know, what should you probably do?
just plug in
Do the
DC.
distance formula.
I mean, 2D. I am
Of DC.
So if we can't cheat and find the length of that line, it's probably smart to do the distance formula.
Okay.
So I went over 2B, and then to get here, I went over
2D.
2D. So how far is it from here to here? It's 2Ds, right? But how far is it from here to here? 2Bs. So if it's 2Ds from here to here, it's 2Bs from here to here, what do I have to take out of this piece to scoot over? I have to take away 2Bs. So you can use the distance formula to prove that.
Oh, I was just doing that.
Okay, so here's the distance formula from here to here. The square root of x2 minus, x2
2D minus 2B squared minus 2C minus 2 plus shoot.
So 2c's minus 2c's is what? 0. That becomes irrelevant. Now, what is the square root of this quantity squared?
4D squared
It's
minus
just
It's
2D
this.
minus 2B.
It's 2d's minus 2b. This square root and this squared cancel each other out. So dc is the length 2d minus 2b. That was weird, right? So think about this. If I walk, how many steps does it take me to get over here?
2B.
2b steps, right? If I walk over here, how many steps does it take me to get here? 2b steps. So if I walk back to here, it's 2d steps, but minus 2b steps. That's how we get that length. Now I have to figure out what is the length of xy.
Add instead of y.
So the only way to find the length of xy is to find the coordinate location of both x and y. What is line segment xy? A midsegment. And a midsegment is created by connecting midpoints. So if I went over 2 b's and up 2 c's, how do I get to the midpoint? What's half of 2 b's?
1b.
What's half of 2 c's?
1c.
So this coordinate location is over 1b up 1c. Half of that distance. Does that make sense? You can use the midpoint formula. X2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. What is 2b divided by 2?
B.
What is 2c divided by 2? So using the midpoint formula confirms that the location of x is at BC.
And Y would be DC.
So if I add my x's together, 2d's plus 2a's, comma, 2c's plus 0. This location is at, what is 2d's divided by 2? 2a's divided by 2. 2c's divided by 2. So this is at d plus a, comma c. We ready?
There's more.
We still have to find the length of xy. Get over it.
Wait, I thought you just add.
Oh,
y.
this is one way.
So you add top and bottom right
The distance formula. X2 minus
there.
x1
Is that a d?
What's c minus c?
0.
The square root of this squared is what? That. Okay, here's the mic drop moment. Does it work?
Yes.
Could we just look at that?
Maybe. You maybe could. What is half of 2a's?
A.
1a. What is half of 2d's? What is half of negative 2b's? Does it work?
Yes.
Isn't that great? Like, man, no numbers and like the mid-segment theorem has been proven.
I would rather not numbers.
Oh, so we have to prove it.
We did, and did we prove that the mid-segment theorem works?
So we can't just do that because it's a proof.
So this is the formula. We're trying to substitute all the actual quantities into to verify that it works. Look, I get it, guys. Tough stuff. So I did